So there are certain theorems based on this Fourier series, okay, and then we're going to just look into that. And from an sine nx, and then just to make sure that all of you understand that whether we write down n or m does not matter. The only thing is that when we define the coefficient, that's very important. Okay, so a and b I won't change. But then maybe I can just even write it in this way also. Okay, it's the same. So we have this, and based on this, so we actually can say that if we are basically having a series, and if we are having a set of series, we can actually take out an average. Okay, so the relation, if we are basically having the relation between the average of the function, the relation between average of function and the coefficient. There should exist some kind of relation between the average of the function and the coefficient, okay, and that is actually something which we call as the Parseval relation. Okay, Parseval relation. There is also a theorem based on this Parseval theorem. Then let's just have a look at the Parseval relation first. So today's topic is Parseval relation, and for that we have to actually find out what is the average here. Okay, and then we will see that this is more or less related. Okay, these are all related. So I'm just going to do some steps here. Maybe you can just note it down, and then we just take the average of fx. And in general, if you just take up any relation, you want to take the average of that. You take the a plus b plus c, let's say, divided by the number of variables. It's here. So that's something which we do. And we can use the summation sign, and we know when we use summation means we're talking about something discrete, but here we are talking about a function, okay, and we are talking about so many n values here, okay, so that means we are talking about something which is more or less continuous in nature, right? So that means if I really want to find out the average, I have to take it a continuous relation, right? And we are talking about the entire range, so our range is from pi to minus pi. Okay, so in general, if I just plot it on a number line, this distance is actually nothing but 2 pi. I'm considering for the entire range. So entire range is 2 pi. That means whenever I want to take the average, I have to consider divided by the entire range, right? So in general, when I actually write down the average relation, we are specifically using integration. We have to just write down the average as 1 divided by 2 pi. Why? Because that's the entire range, and that is how we take average. And then the relation that we have. We're adding up. Okay, so we are adding up means it's a continuous function, so we are integrating it and not differentiating it. I mean, not summing it up, right? So it is fx square dx. So this is how we exactly find out the average relation, right? So maybe we can just try doing this. So got it as minus pi to pi, and then x square, right? Dx. Minus pi to pi. Okay. Then we already have the form of fx. So we'll just take that and divided by 2 plus summation en sine mx plus summation n bn cos mx square, the square root of dx. We can just simply square it. Okay, there are no imaginary terms. So there is no issue of taking the conic term and so on. Okay, so that's simple. So that's what I really do to you dictating and explaining everything. It should be easy. So we're not divided by 2. There are 3 terms here. You can see there are 3 terms, 1, 2, 3. Okay, and so if you just take square of that, you're going to get a square of this term, square of this term, square of this term, and then you're going to get the cross terms. That means you're going to multiply this with this with this, and this with this. So I'm just not going to write down the multiplicative terms here. An square sine square nx plus bn square nx plus the, I'll just write it down as first term. I'm not going to write down the terms here. So, the cross terms are eventually going to be 0. Why? Because we know these are orthogonal relation. And at the same time, if I take sine with, a naught, and then I do the integration, I put the limit from minus pi to plus pi, I'm going to get a 0. I can take with cos and sine, okay, and then again I'm going to get a 0, because these are all orthogonal in nature, okay. So that's why even if you take the cross term and do your summations, finally going to get the answer to be 0, okay. So that's why I'm not really consider the cross term, we're just directly going to do it here, okay. So this is something which you already have from our mathematical knowledge, we're going to use it, okay, that's it. So what we do is, therefore, we can just write it down as 1 divided by 2 pi is integration of minus pi to pi. I'm just finding out the average now. Okay. Here I did not multiply it by 1 by 2 pi, I'm just written it down here. That's it. So dx is equal to 1 divided by 2 pi now. Take it out to 2 pi. And then, minus pi pi. Then that one. So a naught squared divided by 4 plus summation a n square sine square nx plus summation b n square cos square nx dx. And then, this term we can actually write it down to be phi I, phi j, maybe. Okay. Maybe we can write it down also. Phi I, phi j. Right? And I is not equal to j. They are orthonormal to each other. So this is the inner product. We have already seen how we actually take out inner product, right? We've done it with phi and fx, if you remember. And when we actually take out the inner product, we're doing it, just integrating it with phi fx. Yes. Right? That's the inner product. So here also it's the same, I and j. I is equal to, one is this, one is this, one is this, there are three, so three summation, right? So that's how you actually take it. So all these are orthogonal to each other, so we can just say that is 0. So we're not going to really look into it, okay? So what we do now is we can just simplify this. So the first term is 1 divided by 2 pi, and then it is nothing, a naught square by 4, okay, and it was dx. So dx, if we integrate over pi to 2 pi, sorry, pi to minus pi to plus pi, it will get 2 pi, okay. Then we can just take out plus 1 divided by 2 pi, okay. You just recall this in the last step, whatever we have done. This is n, n is a constant, I can just take it out, and then I'm left out with minus pi to plus pi, and then sine of square of nx dx. That's one term that we have, plus 1 divided by 2 pi function nbn integration of minus pi to plus pi, then it will be cos square nx. So let's just simplify this. 2 pi, that's cancelled here. It will be a naught square divided by 4, okay. So even if you're not looking into it like what I am doing, you can do it on your own, and then obviously you should all arrive at the same result, okay. So it's sine square nx, okay. I think it's the square here, right? Square. Let's check. Yeah, two have a square, right? Sorry. Square here. This is square. Yeah. This is sine square nx. So you can just write it in terms of cos, and then if we just do it, put the limits and everything, okay. I will just take this minus pi to plus pi. Okay, I'll just take this value. Okay, we'll do the calculations. And you can see it. And then this is 1 divided by 2 pi summation n bn square. Okay, then this is half, and here also it should get 2 pi. Right, so we'll take cos square, cos 2 is equal to 2 cos square x minus 1, and then you just do your calculations, you should get these results. Okay, so now what I do is, if I just take out half out of it, okay, what I'm going to get is a naught square by first term. The second term is half, I'm taking it out, so it is 1 by pi. Okay, and then this is nothing but summation a and square. Okay, half I've taken, so sorry, 2 pi gets cancelled, so even 1 pi is not there. Yeah, 2 pi gets cancelled here, 2 pi gets cancelled here, half I've taken it out, and this is fine. And plus summation n bn square. As a Parseval relation, it says that there should be a relation between the average, and this is nothing but your average of fx. No? That means average means 1 divided by 2 pi integration of minus pi to plus pi fx square dx. That's the average. This is the relation. So if we take average of this, you will get the relation between the average of fx and the coefficient. So we have the coefficients here, a of a and b. So there is a connection between the two. Okay, and this is actually called the Parseval relation. Okay, so this is important. So the next topic is actually Fourier transform.